A particle is moving along the y-axis. Let's sketch the graph. So moving along the y-axis. So the direction might be upward or downward. Okay, next question. Next sentence. The position of the particle at time t is greater than or equal to 0 is given by y of t equals y cubed minus 4y squared plus 7. From second sentence, we know the position of the particle. We know the function of it. But one thing I want to say is, because you see this y of t, so that means t is an independent variable. So normally on the right of the equation, they will use the letter t to express this function. But in our question they just use y, so it's fine. But we need to remember it here. Y means t. Okay, so next, which of the following expression gives the total distance that the particle traveled in the first 4 seconds? Every time, I said many times, if they require us to evaluate the total distance in some period, and we need to check during this period if this particle changed the direction. It's very important. Every time you need to check it, because if during the period they give us the particle changed the direction, then when we do integral, when we integrate the function, we need to break the integration into 2 parts. So if, for example, if this is 4 minutes, so we would have a positive area or distance and a negative area or distance. So we need to check if this particle changed the direction. How to find if the particle changed direction? It's very easy. We just need to set the velocity function to be 0 and evaluate the t. And if t is between 1 to 4 seconds, then that means it changed direction. If it's not, for example, it's 5 minutes, it changed direction, then it doesn't matter. Okay, let's do it. So okay, first we need to check if it changed direction. We set the velocity function and let it to be 0. But now we only have position function, so we need to take the derivative of the position function. So Fy of t equals 3y squared minus 8y, and set it to be 0, and we factor it. So one is 0, another one is 8/3. So that means at the time the particle at time equals 0, it began to move, and the second time it changed direction is y equals 8/3, which is approximately equals to 2.76 or 776. So we can tell this time is between 0 to 4. That means it changed direction during the period of 4 seconds. But now we have another question. And from the 0 to 8/3 seconds, we don't know is positive or negative. It changed direction, but we don't know. The first part is negative, the second part is positive, or the first part is positive, the second part is negative. The easiest way is we just plug in some value and check it. So for example, we plug in 1, because 1 is between 0 and 2.67. So V0 equals 0 times 0 times 3 minus 8. So it is 0. Oh, I said we should put, sorry, I said we should plug in x equals 1. So V1 equals 1 times 3 times 1 minus 8. So it's negative. So that means the particle at first go downwards, then go upwards at some point. Okay, so now we have the expression negative integral from 0 to 8/3, because that part of area is negative, so we add negative in front of it. Then integrate the velocity function. So then plus from 8/3 to 4 seconds, the same function dy. So we should choose D. Okay, next question. If integral from 0 to 4 of f of x dx equals 10, and integral from 8 to 0 f of x dx equals negative 23, what is the value of integral from 4 to 8 f of x dx? We can use the fundamental theorem of calculus for integrals to find this. So, as we know, from 0 to 8, f of x equals from 0 to 4. So it's like just break the integration into two parts. So f of x dx plus 4 to 8 f of x dx. So here we can see that is what we need to evaluate. But we need to find the value of this and this. So we found that they give us from 8 to 0 equals negative 23. And as we have learned, 8 to 0 f of x dx is equal to negative integral from 0 to 8 fx dx. So that means negative 23. So that means integral from 0 to 8 f of x dx is negative 23, which is 23. So here we have 23. Another integral from 0 to 4 equals 10. So 23 equals 10 plus integral from 4 to 8 fx dx. That means it is equal to 1, 3, so 13. So we should choose C. Okay, next question. 34. If f prime of x equals 3 sine x plus 2 cosine x and f of 0 equals 5, find f of x. To find f of x, we need to integral f prime of x. And okay, dx, and we separate it into two parts and integrate them respectively. So the first one is negative 3 cosine x plus 2 sine x plus constant. Don't forget the constant. And now we need to solve for the constant. Okay, from the given condition, f of 0 equals 5. So this is the fx function. So we plug in x equals 0. Okay, so f0 equals negative 3 cosine 0 plus 2 sine 0 plus constant equals 5. So cosine 0 is equal to 1. So it's negative 3 times 1 plus 2 sine 0 equals 0 plus constant equals 5. So it's negative 1 plus constant equals 5. So constant equals 6. Oh, we don't have this choice. So that means we make an error at some point. Negative 3 cosine 0 is 1. Negative 3 plus 2. Negative 1 plus c equals 5. C equals 6. Okay, here. Negative 3 plus 2 times 0. So this is equal to 0. So it's negative 3 plus c equals 5. So c equals 8. So we should choose B. Okay, next. The graph of f is shown below. Which of the following is true about the function at x equals 5? So that is a function of f and point 5. Now the first choice, A, f prime of 5 is undefined. So at point 5, we know there is a cusp, which means there will be a vertical tangent line. So at point 5, the derivative of f of x is undefined. So A is correct. Okay, B, f of 5 is undefined. The B is wrong because f of 5 equals 0. Okay, C, f prime of 5 equals 0. No, it's undefined because it's tangent line, and as we know, tangent 90 degrees equals undefined. Okay, so C is wrong. D, none of the above is true, so D also is wrong, so we choose A. Next question. 36. The function f is defined by f of x equals e to the negative x squared over 4. What is the area between f and the x-axis from x equals negative 1.65 to x equals 1.65? And we know the area of a function. The formula is from integral from a to b f of x dx. So in our case, a equals negative 1.65 and b equals 1.65. fx equals e to the negative x squared over 4 dx. Oh, we found this integrand. We can't solve it by mind. So I will have to use a calculator. So by using calculator, we get the value is 2.682. So the answer is C. Next question. The average value of the function f of x equals ln squared x on the interval 2 to 4 is. This problem requires us to be familiar with the mean value theorem for integral, which is, the formula is 1 over b minus a, integral from a to b, f of x dx. So this is the formula, and according to this formula, we have our expression, which is b is 4, a is 2, 1 over 4 minus 2, integral from 2 to 4, and our function is ln squared of x dx. And we can evaluate this integral on our calculator because we don't know how to evaluate this integral analytically unless you are very good with integration by parts. So it's easier for us to use calculator to evaluate. So the answer is 1.204 after we use calculator. Okay, next question, 38. Oh, this problem is testing our knowledge of the second fundamental theorem of calculus. It is important. This is important knowledge. So the formula is d over dx, integral from a to u. A normally is a constant of f of t dt equals f of u times du over dx. Okay, in our case, it should be equal to f of u, which u means 3x, and times du over dx. So du over dx is equals 3. So f of 3x, fx, in our case, f of x equals cosine x. So f3x equals cosine 3x times 3. So we should choose D. So this formula is very important. You must memorize it. It can make our calculation very easy. Okay, next question, 39. The graph of the function f shown in the figure below. So this is the function of f of x. Okay, for which of the following values of x is f of x prime of x positive and decreasing? So our point needs to satisfy two requirements. The first is f prime of x is positive. The next is f prime of x is decreasing. So f prime of x positive, that means the function is increasing in that interval. So f of x, f prime of x positive means increase. So which part of the curve is increase? First is this part. I use another color. So this part. From here to here, f prime of x is positive, is increasing. Another part is this. We call it segment A, and we call this part segment B. Okay, they also require f prime of x decreasing, which means when the derivative of f of x decreasing means the second derivative of x is negative. So we know when the second derivative of f of x is negative, that means the figure is concave down. So it's like this. Okay, so which segment the curve is concave down? So this one obviously is concave up. So this one, segment A, is our answer. So any point on segment A satisfy our two requirements. Okay, next question. Because we don't know where A, B, C, D are, so we can't choose. Okay, next question. 40. The radius of a sphere is increasing at a rate proportional to itself. So if we translate the first sentence into an equation, so we can have dr over dt. The radius of a sphere is increasing at a rate proportional. So we set a constant k, proportional to itself. So we have this expression from first sentence. And the next, if the radius is 4 initially, that means when t equals 0, radius is 4. Next, and the radius is 10. When radius is 10, after 2 seconds, radius 10, so t equals 2, r equals 10. They asked what will the radius be after, so they asked when t equals, after 3 seconds, t equals 3, what is the value of r? So this is not a related rate problem. It is just a differential equation. Okay, for differential equation, the first step is always separate the variables. So dt times kr equals dr, and separate the variables, so we need to remove the r to the right, so k times dt equals r1 over, this is r, 1 over r times dr. Now we need to integrate both sides with respect to t. We just need to integrate both sides. Okay. So next, the left is equal to kt. The right equals ln r plus we set c anyway, for example, like this one. Okay, so ln r equals c plus kt. So r equals what? Equals ec plus kt. Equals, we do it again. Here we use another exponential identity. So em times en equals em plus n. So this we can separate as ec times e to the kt. So we set another constant, capital C times e to the kt. Now we just need to plug in the information given by the question. The first one is t equals 0, r equals 4. So we plug in this first. We need to have some space. I write notice that we set constant c, the last constant c equals e to the c to simplify our expression, and also can make our calculation easier. That is our goal. Okay, now we have enough room. Okay. So r equals c times e to the kt. Okay, now we plug in. T equals 0, r equals 4. So 4 equals c times e, k times 0 is 0. So 4 equals constant, capital C times 1. So we have our constant now. So now r equals 4 times e to the kt. Now we plug in the second condition we have. So t equals 2, r equals 10. So r10 equals 4 times e to the 2k to solve for k. So this is 5 over 2 left. Right is e to the 2k. So that means ln 5 over 2 equals 2k. So k equals negative ln 5 over 2. So now we have our final equation, or we say final function. So r equals 4 times e to the negative ln of 5 over 2 times t. The last step is just need to plug t equals 3 into our function and solve for r. So we can use the calculator to evaluate this. Expression, and we can get our r is approximately equal to 15.81. So we should choose A. Okay, next question, 41. Suppose f of x equals the integral from 0 to x of t cubed plus t dt. Find f prime of 5. So obviously we need to find f prime x first. So it's d over dx. Integral from 0 to x t cubed plus t dt. This is obviously another second fundamental theorem of calculus question. Okay, we need to use this theorem again to find the derivative of the integral. So don't forget our formula, d over dx from a to the u, and f of t dt equals f of u times du over dt. So by use this formula, we can have our derivative function is d over dx from 0 to x t cubed plus t dt equals f of u, which is u, x is u. So f of x times du over dt. So take a derivative of x, so which is 1. So that means it is equals f of x. So this f is this function. So I should use another letter to represent this function. We call it gx. So our answer is gx because we already have f of x. So here we use gx. So gx equals x cubed plus x. So that means g. So here gx, I write here. So gx equals g of 5 equals 5 cubed plus 5. So the final answer is 130 because 5 cubed is 125 plus 5 is 130. So this is A. Next question, 42. This is a simple integral question that we need to use method of integration by parts. So this is the first time we do a question by using integration by part. Integration by parts. So the formula for integration by parts is integral of u dy equals u times y minus integral y du. So this formula is very important. When the method of u substitution doesn't work, we always need to think about this formula. Okay. So let's do it. Integral ln 2x dx. So which one we should set it to be u? Which one we should set it to be x? In our case, we should set u equals x. Oh, sorry, we should set v equals to x, v. So there is a trick, and whenever we use integration by parts, we need to decide set which part to be u, set which part to be v. There is a trick. We'd better to let dv over dx. So that is our trick. Always make dv over dx. So that means the other part we set it to be u. So in our case, we set u to be ln of 2x. There is a sequence of u when we use integration by parts. So normally, if there is a ln x in the integrand, normally we set ln of x equals u. If there is a x in the integrand, normally x or x to the n, that means the a power of x, normally we set x to the n as u, unless there is another part, unless the other part is ln of x. So that is a sequence of set u. Okay, and the last one is trigonometry. So the last one is trigonometry. And sometimes we have to use integration by parts twice to find the value. So and sometimes you have to just try let this part to be u, let the other part to be v. But overall, this is the sequence, and always make dv over dx. Okay, so in our case, that because ln of x is in front of x, the power of x, so we set u equals ln of x, and v equals x. So we write it. So integral of u dv equals uv minus integral v du, and in our case, u equals ln 2x v dx. So equals u times v. U is ln 2x. Okay, times v is x minus integral v is x. Du is du equals, because u equals ln of 2x, so du equals 1 over 2x, and use chain rule times 2 is equals 1 over x. So here is, we write it directly. So it's x times ln 2x minus x d ln 2x equals 1 over x dx. So next step, we just simplify it. It's integral 1 dx. So which means x ln 2x. The integral of 1 equals x minus x plus constant. So we should choose C. Question 43. Given f of x equals 1x is less than or equals to f of x equals ax squared plus 3bx plus 14, and 1x is greater than 2, f of x equals 3ax plus 5b. So this is a piecewise function. Find the values of a and b that make f differentiable for all x. First, in order to be differentiable, f needs to be continuous. So in our question, that means if we plug 2 into both pieces of function, they should be equal to each other. So we plug in x equal 2. Okay, a times 2 squared plus 3b times 2 plus 14. Okay, another piece. When x equals 2 is 3 times a times 2 plus 5b, and simplified 4a plus 6b plus 14 equals 6a plus 5b. So 2a minus b equals 14. That is the first equation we get. The second step, in order to be differentiable, the next condition we need to satisfy is if we plug 2 into both pieces of function, we should get the same derivative. So first, we need to take the derivative of 2 pieces of function. So the first, when x is less than or equal to 2 is 2ax plus 3b, and when x is greater than 2, it's 3a. And in order to be differentiable, so we need to satisfy so we take the derivative of function x and plug in x equal to again. So 2a times 2 plus 3b equals 3a. So it's a equals negative 3b. Okay, now we have another equation. So now we have a system of equations and solve it. So 2 negative 3b, we substitute negative 3b for a back into the first equation, minus b equals 14. So negative 6b minus b equals 14. So negative 6b equals 14. So b equals negative 2, and plus plug b equals 2, b equals negative 2 into the second equation and solve for a. So a equals negative 3 times negative 2, which is 6. So we should choose A equals 6, B equals -2, which is B. Okay, next question. 44. A circular shock wave is spreading from its point of origin at the rate of 640 square meters per second. So if we translate the first sentence into an equation, so it is dA, we set A to be the area. dA over dt is 640. Okay, next sentence. How fast is a point on the boundary? So we scratch this graph. So this is origin, this is the boundary, a point on the boundary. How fast is a point on the boundary of the shock wave moving outward in meter per second when the boundary is 100 meters from the origin? So the boundary is 100 meters, means the circumference of the circle is 100 meters. Okay, and they want us to evaluate how fast is a point on the boundary of shock wave moving outward. So they want us to evaluate dr over dt. So we need an expression connect variables a and r. So a equals, because this is circular, so because this is a circle, so a equals pi r squared. And if we take the derivative of this equation on both sides with respect to t, so we can get our new equation as dA over dt equals 2 pi r times dr over dt. So from the given condition, dV over dt is 640, and 2 pi times r over dr over dt. So we need to get the value of dr over dt. So now, except dr over dt, there is only one variable, that is r. So we need to solve for r first. Another condition they give us is the circumference equals 100 meters. And the circumference formula for a circle is 2 pi r. So 100 equals 2 pi times r, which means r equals 50 over r. Over pi. So over pi. And we substitute 50 over pi for our r times dr over dt. So now we can have our value. We cancel pi. So right is 100 dr over dt. And left is 640. So dr over dt is 60.400. So 3 decimal places. So we should choose D. Okay, the last question. Find the distance traveled to 3 decimal places in the first 4 seconds for a particle whose velocity is given by v of t equals 7 times e to the negative t squared, where t stands for time. And if we want to find the total distance traveled by a particle, we need to watch out if the particle changes the direction in the interval they give us. So in our case, we need to check if in this 4 seconds this particle change direction. So one is the one way of the particle change direction. So it's when velocity equals 0. So, but in our question, the velocity function is an exponential function, and as we learned, exponential function is like this two graph, and from the graph we can tell the range is always greater than 0. So that means velocity is always greater than 0. So that means, which means the velocity will not change direction. So we just need to integrate the velocity function directly to get the total distance. Equals integral 7 times e negative t squared dt. So now we have another problem. We can't take the integral of e to the t squared. So that means this question, they wants us to use a calculator to solve it. So we solve it with our calculator, and the answer is 6.204, 3 decimals, please. 3 decimal places. Okay, that is our final question. Next, we will begin section 2.